So there are a whole bunch of different ways of taking a sample from a population. So yesterday we talked about convenience samples, voluntary response samples, cluster samples. The best way usually, now there are super advanced techniques that people use to find something better, but generally speaking, what's called a simple random sample or just a random sample is the best way to get a sample that's most representative of the whole population. So, we talked about making sure not to miss a particular group. And so what can happen is people are like, well, I want some from this group. I want some of the people who are in choir, and I want some of the people who are in debate, and I want some of the baseball players and all these other kind of things. Sorry, did I leave orchestra out? Sorry about that. Right? But the problem with doing that is that then you may accidentally leave a group out entirely. So if you take a random sample, you should get some people from those groups, but you may get people from a group that you hadn't thought about also. Okay? So a random sample should be representative of the whole population. Therefore, you can use random samples to make inferences or predictions about the characteristics of the whole population without having to measure every single item in the population. I'll just tell you that right now I teach AP statistics, and we're doing inferences. We'll do inferences for, I don't know, about 2 months. We do stuff that's a lot more complicated than you guys will do, but it's the same idea. You're going to take a sample, and from that sample, you're going to try to infer what the whole population is like. All right, so here's what we're going to do. The situation is this. Early in the spring, only 100 robins have migrated to the small town of North Zulch. That's a real place. A researcher wants to know the mean weight of all of these birds, but it's not practical to catch all 100, right? So she plans to only catch 10. You are going to simulate her experiment. So in just a moment, I'm going to give you 2 pieces of paper. One of them is going to look like this. It has the weights of all 100 robins in the town.
What are they feeding them?
It's in grams.
Oh, okay.
It's not in pounds. 110-pound robin. that would be I'm picturing the house cat who's sneaking up on it, and that wouldn't go well. All right. The other sheet of paper you're going to get is going to be this one. Now, don't freak out.
Too late.
So I'm going to show you. Your student number is going to be the number on your desk. So I'm going to show you for desk 3, since no one's sitting there. There are 2 numbers under bird 1. The first number is the row, and the second number is the column. So I'm supposed to look at row 7, column 1. I'm going to go to this. I'm going to go to row 7. And it may be helpful to you to just go ahead and 1, 2, 3, 4, so you don't have to always count them. So it's row 7, column 1. It's 98. Okay, so that the first bird you caught weighed 98 grams. That makes sense? And then you're going to go through all 10, and you'll put those 10 on this little chart here. Okay, so again, which student number you are is the number on your desk. Please find all 10, fill it out, and then find the mean of your sample. Okay?
Okay.
All right. So if you want to go ahead and label the rows and the columns, that might not be a bad idea.
the row. And then you look at the second row.
And that tells you which column.
You can't go too fast.
So look, you got your row. Say you have 2. This is your row 2, 6. Then you would have 87.
Wait, how do I know which
I'm sorry?
Your row. Look.
So
So this is your desk number.
So
You don't
this
care
is
about your
student
desk
number 4. So
This,
row
look
3,
at
column
this.
1.
So your first row is going to be row 10, column 9.
So it's
Oh, and then you go 10 down and then the 9th column.
Okay.
That's your
And it makes it easier if you just number everything.
Yes, sir.
Like,
Oh,
look at mine.
I
Look,
see.
we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the way to 10. Both sides. Make it
Zero?
easier. 2 numbers. 10.
Oh, yeah, I know.
what?
What's column 0?
There is a column 0.
What's column 0, sir? Sir? Where's column 0?
3, 4.
Dude is 10.
'What? You want to say that to the class what you just said?
Alright.
Someone's almost cooked up there.
Y'all stop.
So that would be row 10, column 3. So it'd be there. Yep. Alright, stop. Oh, where it says column 0, do that as column 10. So do that like it's 10, 10, yeah.
And we can use our calculator to add it in.
To find the mean, yeah. Did you even do that last one?
No. But it is.
You wanted to make sure. So, go ahead now, add 12 to your number. Not that, to your desk number. So do 19 on there also, please. You can just write it like underneath that one. Thank you.
There will be no cheating.
What are you doing? Alright, so you're done. Add 12 to that, that's 18. So do student 18. Yeah. Yeah, when you divide that by 10, what is it going to be? You should be able to do that without having to type that in.
Wait, do you have 12 or 10?
Alright, once you have your mean, I want you to add 12 to your desk number and do it again. So that you get a second sample.
Wow. I only have 3. For some reason I only have 9. I did everyone, but I think I did everyone. But obviously.
Wait.
7.
So if you circled the numbers on the chart the first time, you may want to box them the second time. And you may catch the same robin again. That's okay.
Where's the little, do we just draw a new little box?
You just put it right underneath the first box.
You said add 12?
To your desk number.
Alright.
Paul, what'd you call?
So you're gonna do 20, right?
Yeah.
I'm 24.
It says
I am 24 years old.
Mr. Davis, only 9 on here.
Oh.
10
So
on
that means you missed one.
Yeah.
What?
Alright, so
What are you talking about?
31, you have that. 49,
49.
Oh.
54,
Fried chicken. Oh.
37,
Okay.
9, 10,
yeah.
49.
Okay, so 49 happened twice.
That's
So you're gonna get 97 twice. You caught that bird and then you caught that same bird again. And that happens sometimes.
I caught it too.
I caught that bird.
I caught the same bird 3 times. I made it twice in a row. The first time I caught it couldn't stop.
Guys, quick, we only have 14 minutes.
This is great.
What about the same bird?
Bad. 6.
At least we didn't come in time. I'm just saying at least we didn't.
Wait, when it's 0, it's 10, right?
Yeah.
Alright. 110. Do you guys know just calculating?
It's easier.
82.
What?
Jeez, I got a quick one.
Hundreds. Imagine getting 100.
Oh, that's what it was. I thought someone was hurt.
Where were you at the average for the one where you had 12?
I don't know, I just put like.
So you wrote it here?
Yeah.
And then just do it up. Yeah, do it there.
We caught the same bird twice in the first two.
Right down the
Wait, I've caught this bird 3 times.
All right. Do you have both of your means? Could you tell me what they are, please?
65.4 and 75.9.
I have mine.
Okay.
85.1 and 83.3.
Thank you. Mr. Johnson, do you have yours? Your two means?
My 2 means are 82.9 and 82.
I got mine.
Those are really close together. Yes, Paul. 81.4? 84.4. Thank you, sir.
Barrett has his.
Yeah, I got mine.
Okay.
89.2 and 72.9.
Mr. Davis.
That big difference.
Okay.
I just caught the same bird.
What light bird?
Bella, you have yours? Yeah. Shh.
I have 82.2 and 76.5.
76.5. Thank you. Christian, you have yours?
74.5.
74.5. Thank you. And
86.1.
86.1.
I got 77.9 and 79.2.
All right. Is there anybody we don't have yet? Is that everybody?
No.
Okay. Sammy, what was your first one?
76.4.
76.4? That should be enough. I know it's not everybody has both, but that's okay. All right, so you calculated the mean of your sample. Do you think your mean is representative of the population? So here's a question here, and it's a subtle point. Do you think your mean is exactly the mean of the whole population? Probably not. Do you think it's a big enough sample where you're like, it should be close?
Yes.
It should be. We randomly picked, and I used a random number generator to get all those numbers. So we randomly picked 10 birds. So yes, it is representative. What inferences can you make about the population from your sample? So the mean of the population is likely to be near, and then write down whichever one you did first. Maybe it was 86.7 grams. Okay. But when you did your second sample, was it exactly the same as the first? No. That's called sampling variability. When you take one sample, it's not going to be the same as the next sample. Every sample is going to vary slightly. So we're not going to take the time to write down all of these. I already have them in the calculator. And what I'm going to do is I'm going to tell you, it just is, I don't know. The average,
My second one was 92.9.
oh, 92.9. All right, I'll go back and add it real quick. 92.9. You must have one of the big birds.
Yeah, I had 2 115.
Gotcha. All right. So this particular calculator will tell you all kinds of stuff, but one of the things it'll tell you is the mean. It tells you the mean is 80.9. So the mean of the means turns out to be 80.9, and it's 80.92 if you want to get exact about it. Were your numbers all pretty close to this?
Yes.
Relatively speaking? All right. Let's look at what a histogram is going to look like for this one. And I'm going to use my calculator to do the histogram just to save us some time. And I'm going to set it so that it is a bin width of 3. All right, so it looks sort of like this. So between, and actually let me tell it to start at a whole number. That'll be nicer for us also. Well, someone think they have the smallest bin or the smallest average?
I might.
What do you have?
72.9.
Ha! I have 65.4.
Okay, anything smaller than 65? All right, so let's tell us we're going to start at 65.
39?
49. And your average? Oh, not my average. No.
Yeah, no, not individual bird, but for your mean.
65.4, guys.
Okay.
I'm the smallest in always.
So look at how many of these are all kind of piled up here in the middle. Notice how it's high in the middle and low on the ends? It's symmetrical. We would expect that. Okay? So our histogram is symmetrical. We would probably expect, and if we had done, there are this is set up for 25 people to do it, and we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 18. So we're missing some of them. Well, everyone did 2, right? So we only have 18. If we had more, what we would probably expect is that right here in the middle, this would be a little bit higher. Okay, so that shape where it's high in the middle and it is symmetrical is a normal distribution. So I'm just going to draw that. I'm not going to do this whole thing because we're a little short on time. You guys worked pretty steadily, but it takes a little while. Something like that is a normal distribution, or sometimes we'll say that it's nearly normal. There is a thing, there's perfectly normal, but that's almost never happens. In a normal distribution, there's a high count near the middle of the data, and then the count goes down on both sides. So you have this single peak, and then it's kind of stair steps down each side. Okay? There's a lot of things that have normally distributed data, such as the height of adult women worldwide. If you were to find the height of every woman in the world and you were to do a histogram, it'd be high in the middle and then it would go down. There's a lot of people that are sort of middle of the road in terms of height, and then there are fewer people that are really tall or really short, right? Well, that makes you special. You're not average then. You're not ordinary.
Extraordinary.
Or abnormal. Take your pick. Just teasing you. Barrett, I don't feel like I have your full attention, buddy. Yeah. I feel like whatever you're looking at on the iPad is causing you not to listen fully. All right. So that's what I want you to get out of this, is that this is a normal distribution. Single peaked, high in the middle. The mean and the median will be almost exactly the same. All that kind of good stuff. All right.